Okay, good morning everyone. Am I audible?
Yes, sir.
Just wait, I am starting. Hello. I'm class 8 Okay, good morning everyone. Am I audible?
Yes, sir.
Yes, sir.
Okay, just wait, I'm starting. Okay, so very good morning all of you. So we have discussed in our last classes, this is our stress space analysis, and last classes we have to discuss different types of differential equations using the state space analysis method. Okay. Uh, Okay, so today we will discuss also these topics. This is skew symmetric matrix. Okay, and there also we have to discuss the different types of equation using the state space analysis also. Okay, so we have discussed last classes this state space discrete time. State space equation. This is the x of a plus 1. This is equals to, we know that g of xk plus h of uk. Okay, so this is the basically one of the discrete time state equations, we have to express at a linear time invariant. It is basically a linear time invariant discrete time state equation. Okay, so now by a recursion procedure, and the Z transform method, then we discuss methods for computing that is, we know, Z into I minus G inverse. Okay. So now finally we treat the equation, sorry, the solution of the linear time varying discrete time state equation. So we have to express that is also x, sorry, this is x of k plus 1. This is the gk into xk plus hk into uk. Last class we have to discuss this of the linear time invariant discrete state space equations. Okay. So here you can see this is basically x of k plus 1, and here k, you know that the range is 0 to infinite. So when k is changes, the value of also is gk and xk. These are the basically changes also. So this is called the linear time invariant discrete state space equations. Okay. Now from these equations we have to solve the skew symmetric matrix method. So now the solution of the linear time invariant discrete time state equation. So in general method, we have to express the discrete time state equation. Basically, it is easier to solve the differential equations because the solve by the recursion procedure. So we have to apply the previous the recursion procedure. So this recursion procedure, it is basically simple and convenient of the digital computations. So the recursion procedure is quite simple. And convenient for digital computation. So that means x of k plus 1, this is equal to g of xk plus h of k. So this is equation number 1. And output of the equation, that is yk, is equal to c of xk into plus d into u. This is the output equations of the given pulse transfer function. Now, the solution of equation number 1, for any positive integer that is k. You know that k is changes, that is 0 to infinite range, positive integer also. So the positive integer k may be obtained directly by the recursion method. So recursion method. Okay. So these are basically first, that is x of 1. This is equal to first of term, that is when k is equal to 0, that means 0 term gdx0 plus h of u of the 0. Next x2, this is also g of x1 plus h of 1, and this is the basically changes of the recursion method. This is, we have to express second, that is x of 2, that is g to the power 2 highest power, x of 0 plus then g of h into u0 plus h of u1. So this is the basically recursion method we have to apply the next steps. Now and so on, this process is continuing. That is x of 3, what have to do? So this is the g of x2 plus h u2, and also you have to express this equation recursion method, g3, that is g to the power 3 x of 0 plus क्या होगा g to the power 2 h into u0 plus next g h u of 0 plus h u, that is h u 2. This is 1, this is not 0, this is 1. This is the 1. So and so on. So up to n number of terms you have to apply it. This is dot dot dot. Okay. So by repeating this procedure, we obtain the equation is coming here. You can see x of k this is equal to g to the power k x of 0 plus a summation of j is equal to 0 to maximum is k minus 1. That means before the infinite of the power, and g to the power k minus j minus 1 into h u j, where k is equal to, you know that, 1 2 3 dot dot number of in terms. So this is the basically complete equations for the linear time invariant discrete time state equations. This is equation number 3. Okay, so here this xk, it has the two parts. Okay, so one, it is representing the contribution of the initial state of x of 0, and another contribution of the, that is the q of j, where j is the basically value 0 to k minus 1. So here x of k consists of two parts. Okay, number one represents the contribution of the initial state that is of x of 0, and the other contribution of the initial state of input u of j, where j is equal to 0 1 2 3 dot dot maximum is k minus 1. Okay, so this is for the input equations for the linear time invariant discrete time state equation. Now the output equations. So the output, that is yk, you know that yk is given by y of k. This is equal to c, you know that previous equation, c of g to the power k x of 0 plus again c summation of, you know that range is 0 to k minus 1 into here g to the power k minus j minus 1 into h u j plus another part d of u k. Okay, so this is the basically expressions for the output of the linear time invariant discrete state time equations. So this is equation number 4. Okay, is it clear all of you? So please remember these two equations. This is the output equations and this is the input equation. So this is the basically linear time invariant discrete time state equations. Okay, is it okay all of you?
Yes, sir.
Now from here we have to calculate the skew symmetry, sorry, state transition matrix also. Okay. So I am go the next page. This is the new topics. State transition matrix. Okay, so here we have to calculate the state transition matrix for the linear system solutions. Okay, so the state transition matrix is used to find the solution to a general state space representation of a linear system in the following form. Okay, in the following. So we have to express here that is x dot t in our state space analysis. So this xt, that is the ut xt plus another term bt ut, and another one when xt time is 0, this is equal to x of 0, where please remember where that xt is the state of the system, is the states of the system. That we have broadly discussed in our previous classes what is state variable, what is state matrix also. Okay, what is matrix, state skew symmetric matrix. There are the different topics we have tested. That is state variable, state vector, what is state space equations. These are the. So now here this xt is the basically different of the states of the system. Okay, and ut is the input signal, and at and bt, it is basically our matrix function, our matrix function. And another terms that x0, it is the initial condition of t0, that is a starting time, that is a t, sorry, not 2, this is t0. I'm written this is t0. Okay, so these are the basically general linear system equations for the state transition matrix also. Okay, up to this part it is clear all of you. Now using the state transition matrix, state transition matrix, we expressed here that is just like a phi of t, another is tau. The solution is given by this is the expression x of t. This is equal to phi t e0 x of e0 plus integration t0 to maximum is t phi t tau b tau into u tau into d tau. So this is the basically state transition matrix expressions for the phi of t tau of the solutions. Okay. Now here this is the first term and another is the second term. So here the first term is known as zero input response. This one zero input response and represents how the system's state would evolve in the absence of any input. And another term, second term, this is the second term, is known as the zero state response. And defines how the inputs impact the system. Okay. So I'm repeat once again. So this is the basically skew symmetric matrix. Okay. So here the state transition matrix we have to use this to find the solution of a general state space representation of the linear system. So this x dot t atxt plus bt, you know that. And here starting is when t is 0, that is xt0 is x0. So here xt basically the states of the system, different state of the system, x1, x2, dot xn, and ut is the basically input signals here. At and bt, this is basically matrix functions also. And when x0, it is considered for the initial condition, that means when t is 0. Now, so we have to apply the state transition matrix for the variable. So equation is coming this part. So this is the first part and this is the second part. So here first term, it is basically called the zero input response, and it is respond to the system, any system state. It would evolve the absence of any input value of the first zero input response. Another next term, this is second term, it is known as the zero state response, and it defines how the inputs impact the overall system. Okay. So this is the basically state transition matrix. So this type of question is coming in your exam. So ऐसे भी आ सकते हैं right short note from state transition matrix. Okay. Is it okay, all of you? Okay, so everyone write your own name and roll number in the chat box. Prodom is present.
Yes, sir.
Prodom, you take your script, sir. Okay. Next. We have to go the next stage. Next is jet transform. A jet transform approach to the solution of discrete time state equation. Okay, so previously we know the basically continuous discrete time system we have to discuss. So the equation kya tha? You know, x of k plus 1. This is the general equation. G of xk plus h of k. Okay. Now taking the jet transform of both sides. This is equation number 1 here. Both sides of equation 1. So we get that is z of xz minus z of x0. This is the g of xz plus h of xz. Okay. Where you know that xz this is equal to jet transform of x of a and uz this is equal to jet transform of u of k. Then the equations we have to express zi minus g into xj. This is equal to z of x0 plus hu. Okay. Now we multiply both sides of the, this is equation number 2 of the equation 2 by zi minus g inverse h q of z. 1 minute. So this is the basically pre-multiplied by the equation 2 by zi minus gj. So क्या आएगा equations आएगा x of j, this one is equal to zi minus g inverse, sorry, z of x0 plus zi minus g inverse h of, this is equation number 3. Now taking inverse z transform, okay, of both sides in equation that is number 3. क्या मिलेगा? That is, we have to express the final equation of x of a. This is the z inverse of zi minus g inverse this is the zi minus g inverse to z of x0 plus z inverse into zi minus g inverse h is z. So this is the equation number 4. Now comparing equation last, that is the equation 4, we obtain that is g of k z inverse, that is the zi minus g inverse into g. So we obtain the last equation, that is the equation 4, and the equation number previous one I am written just equation. previous topics में ये equation हम लोग देख रहे थे, x of k g of xk plus you know that summation of g is equal to 0 k minus 1 g to the power k minus g minus 1 h u into g. Okay, so this is the basically required equations for the Z transform approach for the discrete time state equations. Okay, so after ending the class, please everyone again join. Okay, so this is the basically states equations for the Z transform approach. So question ऐसे भी आएगा, how Z transform we have to calculate it from a discrete time state equation. तभी आपको ये वाला draw करना पड़ेगा. Okay, is it